Okay, today we will learn how to convert from one number system to another. A number system is a mathematical notation to represent numbers of a given set. And this set is using unique digits or other symbols in a consistent manner. Let's look at some examples of number system. The number system that we are using in our everyday life in mathematics subject is the decimal number system. The decimal number system has 10 unique digits. The number of unique digits is referred to as the base or the radix of the number system. These unique digits are 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So from 0 to 9, there are 10 unique digits. We form a number in this number system by combination of these digits. Example, we write 29 or 29 base 10, or we just denote it as 29. So if a number has no subscript, the subscript here is the base or the radix of the number system. So if a number is written without a subscript, then it is understood that it is in decimal number system. Another example is the octal number system. By the word octal, that means the base or the radix is 8. So the 8 unique digits are 0 until 7. Example, we write 5, 7 base 8. This is an example of a number written in octal number system. Hexadecimal number system is another example of a number system. From the word hexadecimal, that means that the radix or the base is 16. So in this case, there are 16 unique digits, and these are 0 until 9. From 0 to 9, we know that there are 10 numbers or 10 digits. After 9, we will use A to represent 10, B as 11, C as 12, D for 13, E for 14, and F for 15. So the biggest unique digit in hexadecimal is 15, but we denote it with a symbol F in this number system. So an example of a number in this number system is 2C. This is in hexadecimal. So another example of a number system is the computer language, machine language. It is binary number system. So from the word by, from the prefix by, it means the base or the radix is 2. And there are 2 unique digits. These digits are 0 and 1. So the computer can understand only the language that is written in series of ones and zeros. An example binary number is this, 1011. So we put the subscript 2, so we will know that this is a base 2 number or a number that is in binary number system. Now there are many other number systems, unlimited number of number systems. Any positive whole number can be a base of a number system. Now let's try to convert. Converting from hexadecimal to binary. A hexadecimal number system, if we want to convert it to binary, let's take a look first at their bases. So hexadecimal is base 16, while binary is base 2. If we will study the relationship between 16 and 2, we know that 16 is equal to 2 raised to the power of 4. From this knowledge, we derive this concept that one hexadecimal digit can be represented as 4 binary digits. So for example, we have this value C in hexadecimal. How do we convert it to binary? Since we have the idea that this will be denoted with 4 binary digits, that means we'll have 4 blank spaces here, the 4 boxes. The rightmost digit or bit, we call it least significant bit or LSB. So in any number system, the rightmost digit is called or is labeled as LSB or the least significant digit or bit. In this case, bit because it's a binary digit. So the weight or the significance of the LSB is 2 to the power 0. In each place, the value is a power of the base. And the base here is 2. So 2 to the power 0, followed by 2 to the power 1, then 2 squared, then 2 cubed. So if we get these values, 2 to the power 0 is 1, 2 to the power 1 is 2, 2 squared is 4, 2 cubed is 8. C, in hexadecimal, we know that in decimal, in our language, in our number system, this is 12. This is how 12 is denoted or written in base 16. So we write it C. Now, how is this 12 generated? What values from the place value here of the binary digits can be combined in order to have a sum of 12? Okay, so we know that 12 will be generated or will result if we take 8 and 4 together. If we sum up these two, it will total to 12. So 12 is 8 plus 4. That means these places here in the 4 digits of binary will be switched on. It means we will take them in the summation. So we take it as 1 here. That means we switch on this bit. And the 4 place also will be switched on, while the other two will put 0. So 12 is represented in binary as 1100. So therefore, the hexadecimal number C will have the value in binary as 1100.